That's right.
and maybe 40, I've forgotten. But the thing I want to talk about today is how we put ourselves into the rest of the civilization. As physicists, a lot of times we have a ton of work to do just getting the minus signs correct and things like that. And so it's we sort of lose track. And when we talk to other students, younger people, and the people around us, we have to be aware of the fact that we have to make them, bring them back into the world, that we are really part of who you are. And so let me just show you some of the ideas of what I have sort of constructed from this kind of thinking. So let's see if I can go forward. Okay. I always sort of like this comment by Jean-Laurie Fabre. It said that it says the truth. I mean, when you look at how the world is actually constructed and the things everything from the wax on our floors to just the idea of cultivating trees and things like this, you never really hear about how they came about, but you'll hear about some soldier that plundered a village, and you get the dates and times right and leaving know his girlfriend's names. So this is the kind of thing that I'm trying to avoid. So what I want to do is sort of try to make history tractable, bring us back into the world. And then one of the things I'm going to do is actually show you how civil rights history has a lot to do with physics. And it's sort of strange that physicists even brought into this arena, but we're a big part of it more than we're actually trained to believe. And so we study things which are the interactions of things, including the events that make up history. We're deeply embedded in how our world works. You can think of just the story of electricity and magnetism. You can go back as far as you like, but you'll see that it doesn't take a lot of people, but there's a lot of consequences because of our work. So I also want to sort of emphasize that science really isn't really relying on one civilization to do anything. Science is like a serpent. It swallows up what it wants. It doesn't care about the pharaohs of Egypt. It cares about its mathematics. It takes what it wants from it. It doesn't care about the gods of the Greek civilization. It takes the other part of it, and it doesn't care about well, it doesn't care about the Bhagavad Gita. I shouldn't say that. I should have to parameshwar, but it cares about the Indian technology that went on as well as the West. So what science is doing, it weaves its way around our world, our civilizations, and it comes up with something which is so unique, juxtaposed to any particular place where it came from. It brings a bunch of people together in the world. And the way I actually went about this was about 25, 30 years ago. I just got curious about a few questions about things. So I actually started reading more books on archaeology and linguistics just to see what's really going on in our history. So some of the books which I actually looked at was pretty much one of the biggest ones was this archaeological book called Past Worlds, and it's edited by Michael Woods. And there's a variety of other books here which I used in order to think about what mathematics and science have actually done in the history of people. And then there's some at the end. It's interesting that I'll talk about Albert Einstein as well. And so let's get started. So as physicists, and some of this talk is sort of focused on undergraduate students to just let them see how their world is working. But let's just get started. So from a physicist's point of view in 2020, we think that the universe is about 13.7 billion years old. And we have an argument for why it may happen that way, and that's called cosmology. Okay, so that's our starting point. And it took about 4.5 billion years, okay, for Mother Earth to be born. So she's about 4.5 billion years old. But it's an interesting that age of the Earth is a very important fact for human rights, which I'll show later. Okay, so and it took about 3 billion years ago where we had the most trivial or primitive life forms. Okay, and this is also important, but let's just say that's about 3 billion years old. Now, the dinosaur, which is a massive word for a species of several different species of creatures, were around themselves for 250 million years. Okay, and they also were about 250 million years ago that they were here. So they actually lived extremely long and populated Earth much longer than the humans have. And so that's sort of the the state of, if you were to throw a pen into the timetable of Earth and you land on something, you would think that it's almost always dinosaurs for if you look at creatures, because you would just not have any access to when humans were around. About 4.2 million years ago, Australopithecus started to arrive, and that's sort of the beginning of our human ancestry. And this seems to come from the Omo Valley in Ethiopia, where we have found remains of Lucy, the skeleton of Lucy, which suggested that not only was there's a humanoid, but that there was also idea of tools, social life. There were actually evidence of the sons and daughters of Lucy being buried near Lucy. And so there was already evidence, even with the Australopithecus, that there was this notion of a civilization, which is not even our final subspecies. So about 150 years ago, our subspecies, which we would probably call Homo sapiens sapiens, actually arrived. And we are in the family Hominida, and our genus is Homo, and our species is Homo sapiens, where our subspecies is Homo sapiens sapiens. So it's about 150,000 years where I would say that humankind has actually been populating Earth in the type which you were born. So I like to tell people that if you went back about 100,000 years ago, you would actually have a creature which you could teach quantum mechanics to. You don't have to wait till the 18th century. That species, that creature there, pretty much had the biochemical equipment, the brain and everything, in order for you to just bring the quantum mechanics to that person. So you really haven't changed that much in that time, but that's extremely short amount of time. So to give you an idea of how short that time is, so this is our Milky Way galaxy, and there's Sagittarius A star sitting in there somewhere, and we are on Orion's arm right in here somewhere, and I think that's about, well, maybe the astronomy students will let me know how many. I think it's about 10,000 or 20,000 light years from the chewy center of the Milky Way galaxy. So but this galaxy has angular momentum and it rotates. So I'm going to use that clock as an idea of how long the Earth has been around, juxtaposed to how long we've been around. So it takes about a quarter billion years for the Earth to actually rotate from one point all the way about to the other on this Milky Way path. And dinosaurs as a species, not any particular creature themselves, saw at least one full 360-degree rotation of the Milky Way. So they actually, if they were actually sampling cosmology data, if they could have, they would have far more data for us to explore what the universe looks like than we do. We have an extremely tiny slither and not much to go by. Humans have only seen about a third of a degree of that rotation, just to give you, and that's when we started doing more scientific observations, et cetera, et cetera. This just gives us a scale. Now, already at around 25,000 BP means before present, that's an archaeological term. You can already find that science and technology as well as mathematics are flourishing because of that species sapien sapien. And so you see notions of bows and arrows and sewing needles. And as I have this conversation with people, I ask them to think about, would you have been able to invent these things? Would you have been able to develop these things yourself? Okay. And for example, we as academicians make fun of basket weaving as a course, right? We say basket weaving 101 as a joke, but if we were in the middle of a desert and we needed to gather water and we saw straw or something, could you weave a basket that was waterproof? I mean, if you knew what you were doing, sure, but this is a non-trivial idea, and this idea of weaving baskets out of vegetation so that they're waterproof, from my point of view, it just blows my mind. There's already this idea of early farming and early animal husbandry, and this really literally sets off the whole explosion of the humans on Earth. Before then was this idea of this hunter-gatherer idea, But hunters and gatherers could never have generated a population where we have today. When we started doing farming and we started doing animal husbandry, where you can actually keep animals and produce them on where they produce the production and reproduction of animals is under control of the humans, the population blew up. And that's where a lot of the population came from already as early as 14,000 before present. You already see that Lake Chad, which is a desert today, was a massive fishing village. And if you look at Africa's continent, you see an amazing relationship between, say, the west and east sides of Africa, because in a way you can sort of tell that they were already a transportation system. If you look at these weavy baskets and you look at the writings and drawings on the baskets and in the archaeological finds, and you'll find way over in Ethiopia and way over in the Ivory Coast, you'll find very similar artwork and very similar patterns, along with some stuff which is far more indigenous to those areas. But you'll see that there was a sharing of something going on, as well as the fact we know that that was a dried up lake called Lake Chad. So that's called the Sahara now. So around 9,000 BP, the Ashango bone is found in Zaire. And it's basically a calendar, a 30-day calendar, pretty much. And this bone is in lots of households and lots of families who use this bone. And it may have been very, very important for humans simply because for a variety of reasons, but the keeping track of the lunar calendar was done on this bone. So this was one of the earlier uses of this notion of a calendar. It's called the Ashango bone. So humans are doing okay, if you ask me. Now, here's what really sort of, when we talk about as African Americans, you hear the phrase cotton pickers and all this kind of stuff. But if I look at a field of cotton, as a theoretical particle physicist, I can't in my life see how I could come up with this thing over here. Okay, but it does. So humans have figured out how to take a field full of this stuff, cotton balls, and turn it into these cool dresses and clothing and things like this, which is is amazing that we went from agriculture to fashion, and we did it 8,000 years ago. And so that's an example of where the crop growing is a scientific and technological advance, which is very difficult to reproduce without lots and lots of minds and mentality, a lot of humans involved in that process. So around 6,000 before Christ, there's these early cities. And what I'm going to do is just sort of focus on a particular part of the world. Every region of the earth has some interesting scientific discoveries in it, but let me just focus on this particular region right now because it's sort of sometimes neglected, but it's very interesting nevertheless. The calendar used in this valley, the Nile Valley, is the same one pretty much what you use today. It had the idea that there were 365, and they knew there was an integer. They knew there was a fractional number of days. They probably didn't have the 0.25 out perfectly. But the idea of a month called 12-month calendar, there's no physical reason why we have to choose 12 months, but that it's been passed down to us from these old calendars from 4000 BC. They would have ideas of smelting metals and firing kilns built out of massive termite holes. These holes with the termites with these ovens could get that hot, where you could actually smelt metals and such as silver and gold, and already in areas like Mesopotamia. The Nile Valley is a huge hunk of what you're talking about, and I was actually surprised long time ago how long the Nile is. I'm still proud as a St. Louisan that the Missouri-Mississippi River is still the longest river in the world, but the Nile does come close. Okay, so it starts here in Lake Victoria in Tanzania, and the White Nile meets in Khartoum, as well as the Blue Nile coming from Lake Katana meets here. And this rich body of water leaves a massively wealthy silt of minerals and everything here in this region, which we call today Egypt. So it makes sense then that with a river of that size and that scope laying in this continent, that the human species, the human mind would just flourish around this region, and it does. Around 3000 BC, we probably had the first what we call scientists, which we know by name. We know that it's sort of a new strategy to actually call people by name in history around this time. So this first scientist, Imhotep, okay, was a statesman, a mathematician, engineer by today's standards. People would actually call him a physicist if you were to drop him in on us and actually do things. And he built the first stone pyramids, okay, in the third dynasty. And it's important to understand that the pyramids weren't being developed at 3000 BC. They were much older, but they were made out of sand and other stuff. And a lot of the pyramids were just rinsed away because of the products that they were used to make them out of. But Imhotep was the one who said, you need to quarry stone. And by quarrying stones, we now have still have evidence of these pyramids because they seem to be impervious to the weather conditions. This guy was deified as the god of geometry by Greeks later. So it's an interesting relationship there where mathematics, and I'll talk about this in a bit, is almost seen as a language of the gods. And that language was heavily worshipped compared to today. And I think that the reason mathematics is treated differently today is probably because we're too used to it. We're too used to it. It's phenomenal accomplishments what it can bring to us. So the Egyptians had their own number system. If you were to do archaeological digs of a village in Egypt, you would find writings and mathematics and stuff all over the place. Maybe it was, you went to Costco and you have a receipt or something, but at the same time, but whatever they had, the mathematics and writing, people would write all the time to each other. The idea of a sail ship and mirrors and candles, etc., that was all very commonplace at 3000 BC. And it was actually strange to me one time. I had a conversation with a colleague who was surprised that Africans could actually sail ships, and I didn't know where that came from. But it's pretty much, you could not have the world you have today if that had been true. It would just be a desert, and nothing would have happened. So it took about 1 million to 2.5 million of stones, each weighed about 2.5 tons average. And this is an engineer's dream, if you think about it, to take stones, 1 million stones for each of these things, and figure out how to build a pyramid. And so engineers must have been excited by the prospects of going ahead and okay, we're going to solve that problem. And the amount of statics that they would have had to understood, not just by trial and error, but to understand it in terms of some kind of fundamental law, at least at the level of statics, had to be in place in order for it to be done so quickly. So now is sort of dripping with measuring devices. It even has this idea of pumping water. The screw pretty much came out of the Tigris and Euphrates area, where there's the screw. The water screw was used to actually drive water from a lake and lift it up over distances. But here they already had simple machines. They knew what kind of chemistry they needed to cut huge stones and lye and things like this. And they also knew how to bring things to transport these heavy stones. And then they had a system of units was born. And the system of units was carried down from one place to the other in order to maintain consistency with the different pharaohs or gods or whatever they were trying to do. The pharaohs, for example, would actually have, I'll talk about that in the House of Life in a minute, but they would also have this idea with glass works. You could use those same kinds of ovens to melt down some of the sand and produce glass. And canals were built, and there were claims in papyri for the prediction of eclipses, etc. So in some of the readings, which is interesting, we already use scale. I have one of these bathroom scales where you slide the weight over. I like those because they're pretty fun to use and you remind you of classical mechanics. But they were using those things also in these cultures around the Nile River. And what's interesting about them is that they became metaphor, just like we talk about your love pulled me like gravitation. You know, we will use, people are so familiar with this idea of the scale and weighing things that they actually use it as metaphors for other things, such as the law and etc. So in the Book of the Dead, for example, you would see the heart of the pharaoh put on one side of the scale, and a bunch of gold and everything on the other side of the scale. And if this if the scale tilted in the wrong direction, the pharaoh would not be allowed into the gates, because of his heart was not in the right place for the people. This is interesting to take a physics concept and to drive it into poetry, and we see it happening all the time for ourselves. And but you have to appreciate the fact that humans are also doing it back then as well. About this time, the cuneiform writing, this is also along the Tigris and Euphrates rivers, Iraq, Iran areas. And you'll see that cotton is grown in India and other places. And in 23 BC, surgery is actually done. And this papyrus here, called the Smith Papyrus, which shows about 48 cases, not the whole papyrus, just a piece of it, but it shows about 48 cases in surgery. And it has some interesting features if you want to think about it. It talks about bone surgery. There's this idea of prophylactics using intestines of animals and things like this. They would use beer as a painkiller, and that was written into their medical prescription. Can you imagine a physician telling you, take a 6-pack of beer and go home? But that's what they were doing back in those times. And this notion of beer was also used for the workers of the pyramids, and beer was a painkiller for working too hard. Suturing was there. They knew the value of the function of the heart as moving blood around, and they knew the brain was a central organ. And there was no mention, if you look at these things, the translations of the Smith Papyrus, there was no mention of magic or bloodletting or letting a ghost out or you know, something like this, which we see later on in the Dark Ages in Europe. So at this time also, Pythagorean theorem is used, and this is 3000 BC, and Pythagoras is born around 600 BC. So mathematics begins to flourish. The AHMES Papyrus is probably the oldest known human mathematical document that we can find so far. And it's somewhere between 2000 BC and 1600 BC. And it's believed to be, this document is believed to be just a child's homework pad. It's got 84 word problems on it. And these word problems say stuff like, how many cats can you stuff into a basket if the basket were truncated, so on and so on. If you went out into a lake and you dropped a plumb bob and it got wet, so much wet, and you were so many meters from the lake, how much water is in the lake, kind of questions would be in the, so they understood things like the half sphere volume, etc. But the most important thing, which I think I sort of recognized in this, is the inscription on this document, which says accurate reckoning, the entrance into the knowledge of all existing things and all obscure secrets. Now, here's the story which I've been told. Now, it's maybe an urban legend, but let's pretend it's true because it's fun. And that is that the person who found this in around the 1860s, it was in a cave, and he was about to defecate in this cave, and he was looking for something to clean himself with. And he found a piece of parchment, and he started to pull on it, and he started to pull, and this thing was like started to unravel this 18-foot long document. And so he said, okay, well, that's important. I'll go talk to the Egyptologists about it. He cleaned himself up with something else. And when they translated this to him, that the accurate reckoning was the entrance into the knowledge of all things, existing things, and all obscure secrets, from the hieroglyphs into English, he was extremely excited. I mean, so was the whole world, that they had found the fountain of youth, and they had discovered the magic of Egypt, so on and so on. But when they read it further, they found that it was a mathematics document. And so it was, for them, it was a little bit of a letdown. But imagine at the time that the people of that time, they saw mathematics with that same excitement of being able to answer questions without ever having to leave home, just like theoretical physicists do. Or if someone has to figure out how much water is in a tub, you don't need to go and make a measurement and pour water into it and figure it out all the time. You can just compute volumes. So they knew that for them, it was extremely exciting to have mathematics at the time. And maybe that's precisely why we see so much mathematics written in people's homes, okay, all over documents and everything, because mathematics had this sort of magic to it, a power to it, where you're translating the physical world into symbols on a page. You manipulate these pages, and it becomes real. And so in some sense, this is sort of the beginning of what we call theoretical physics, where you take mathematics, you play with it on a page, and if you observe that you have, for example, a circle, and a circle that has nice conformal properties, it'll actually, whatever I do on my paper, it will actually blow up and be in real life. I can expand it in any way I like, and it'll be exactly the same kind of structure in bigger life. So these papers, these documents, such as AHMES and Smith, were known as scholarly works, and they were done in what's called the House of Life, okay? And they were aware of the difference between pure and applied math as a branch of knowledge, and they had their unknown variables, and they would use what is called a regular false side method, sort of a predicting and correcting to solve the equation. So they didn't use what we would normally do to solve problems. For example, the quadratic equation was solved and used, but it would actually, you would guess an answer, you would be overshoot, and you guess another, you back off, and so you sort of predict and correct, and you would iterate on a solution, which is the way they would actually, is what I can tell anyway, the way they would solve problems. Word problems were heavily used, and it was known that pi was the ratio of the circumference of the diameter of a circle. And the thing about this sort of House of Life is that pharaohs sort of took advantage of them as politicians in the following way. Under a lot of these pyramids or other structures in Europe, in Egypt, there would be what are called Nilometers, which measure the water table of the region. And the scribes and the scientists would come and tell the pharaoh, well, our water table is getting a little low. Just wondering whether we have enough water for this time. And so the pharaoh would run up to the pulpit and tell the people, my people, the gods are not pleased with us, and would use it to a political advantage in order to maintain a powerful relationship between the people of the town, and as the intermediate between them and a god. So that's sort of an interesting use of science back then, which you still sort of see vestiges of it today, but hopefully physicists and other scientists don't fall completely prey to it. Now, this work does influence other people like Thales and Pythagoras who visit Egypt. And although Thales is sometimes considered the first scientist, yet he was trained in Northeast Africa. And Pythagoras spent 22 years there studying in the House of Life. And the Greeks took a lot of this and developed it much further, and blew up into a world where mathematics now went on the other side of the Mediterranean and actually became part of the culture of what we now are luckily able to see today. So it was actually torched off, and the Chinese also contributed a great deal. Mostly the North African, later on you'll see that it's the Islamic groups who are actually bringing a lot of this information into Europe. So around 300 BC, Alexander the Great really likes this area of Egypt, and it's very diverse. Lots of different people are there. People are coming in from Greece. They're coming in from the Tigris and Euphrates rivers area, Iran, Iraq. They're coming in from Africa. So this region, which we call Alexandria, Egypt today, was extremely diverse. It had the library had at least 1 million papyri in it, and Alexander the Great liked it so much he named it after himself. He just literally took the name and said, "I like what you guys are doing here, so it's mine today, and you can live because of that." Okay, so Alexander the Great converted this into the Alexandria, and But the library did take a beating. So the library, about 50 BC, Julius Caesar does attack the library. And at one point, I think Cleopatra takes books out of the library and actually uses it to trade, negotiate a trade with one of her enemies, okay, in order to stay in power. But by 1415 AD, Hypatia, who I hope everyone appreciates, was the woman mathematician who was leading much of the culture at that time in that region for science, and she was accused of sleeping with her servant or something, and was pulled apart in front of the Library of Alexandria and stoned to death. Okay, and this is really the beginning of what we call Christendom today. It's not so much as the birth of Christ, but that's really where what we call Christendom becomes a very powerful political organization, and you start to see the Pope becomes related to the generals of militaries, etc. In 600 AD, the library is burned to the ground by a visiting Islamic general. But by this time, the library was shambles anyway. It wasn't really much to it. So it's often the general's often accused of making the statement that, well, you probably know the statement, but I don't think that after 175 years, 185 years of actually being in a wreck, that it really would have mattered. So today it was rebuilt, and there's the Library of Alexandria today, and it's something worth exploring, taking a look at. So let me just switch gears slightly so we can appreciate what happens in our sort of world. And so how does science and slavery have to do with each other in the 1800s? Well, the United States, of course, had its Missouri 2/3, 3/5 compromise, because at one point, one Pennsylvania senator, who was actually a Democrat at that time, okay, wanted to curry favor with the Southerners who owned slaves. And so he said, well, tell you what, instead of taxing you for the full amount of owning slaves, which is the claim, if slaves are your property, then you should be taxed, we will make Black people 3/5 of a human. And so therefore your taxation will go. So this is what the so-called Missouri compromises. And for about 70, 75 years, the United States would equate Black people with 3/5 of a cow or something, in order to get you do the favor of letting people own slavery in a country where we have land that are free. At the same time, you're able to get the taxes. So that was the idea. However, this of course set off this massive moral dilemma about what slavery. Abolitionist groups grew crazily around, and in 1833, for example, Britain abolished slavery completely. However, to avoid this sort of moral dilemma that declared that Black people, so many claimed that Blacks didn't have souls, and so slavery was okay. It was all right. It was a moral thing to do. And furthermore, that Blacks weren't even a species of the Homo sapiens sapiens after Darwin. It was actually Darwin who actually put his foot in and said that's simply not true. Okay. So Darwin is of course, he's Darwin. He's the guy who invented evolution, or whatever the idea is. He makes a trip around 1831 to 1835, pretty much around the worldish kind of thing, which he visits a variety of places, the Galapagos, Brazil, areas like that, and comes back around. And he writes a book called The Voyage of the Beagle. And in that book, he makes very strong claims, which made people uncomfortable. One was, for example, he mentioned that the Aboriginal people in Brazil, if you took the clothes off a woman from the Aboriginal woman in Brazil, she would be exactly the same person as the royals in England. And the royals didn't particularly appreciate that, but he said it. And he also wrote a book called The Origin of Species and in Descent of Man. In The Descent of Man, he actually has a chapter called The Negro as a Subspecies, where he attacks the idea that the Negro could not be a human being. So he was horrified by slavery in some sense. and the fact that all humans are one person is his argument. But there were lots of other people who now were in biology. Spencer, I think, was one of the guys. I don't remember all the details there. But if you read the book, he'll say, unless you invoke the idea of a creationism, then there is no evidence that the Negro is a subspecies. And so this set off a very dangerous issue with the church, because now it said that we were enslaving people as a nation who had souls. And that was a big problem for the church. So um, this tension could be one of the major reasons why Darwin was so much disliked, because it's actually affecting an economic decision in the United States, and him being English didn't help. So Darwin actually discussed his relationship with a Negro man. Okay, and in the book, I actually read the book. It's actually a fun read, but it's really hard to read because of the language is sort of old, and biology was never something I could read easily. But it's a fun read, and so you'll see that Darwin makes it clear that the Negro is not a subspecies. The Negro can never reproduce and produce healthy offspring, such as you're seeing with other people, such as you see in Brazil and New Orleans, if the Negro was a subspecies. This idea of social Darwinism, I threw this in because I keep hearing friends of mine who are full professors in the social sciences talk about Darwin in the same language as social Darwin. It has nothing to do with the guy, and it has nothing to do with Darwin would have turned over in his grave if he heard that it was being related to eugenics. So that's just a statement I'm just going to put out there. Meanwhile, in the middle of all this, the Yale University has graduated its first Black person, and that person gets a degree in physics. And physics is the first PhD for is the first PhD subject for every African American in the United States. And so physics leads the way. Now, people say, well, that's wonderful, but think about the faculty at Yale University. They're the ones who are also mainly responsible for making sure this happens. It's not something that just the guy bought a degree and came home. He's actually cultured. He's developed as a physicist by the Yale University physics faculty. And Yale, I think at the time, had Gibbs and a few other people as well. So Yale is a big. In fact, Yale was one of those universities that saw itself sort of leading the future. Now so in 1876, we already have our first Black anything with a PhD. Okay, and however, by this time, there's a big frustrating argument taking place about what to do with the Negro and as far as education goes. Meanwhile, I'm really impressed by this guy, because at this time, his intellect is being challenged at the biological level by a variety of people, and it's actually Darwin is actually on his side, but at the same time, there's a lot of tension about the intellect of African Americans. The Atlanta Agreement, of course, is this big debate with Booker T. Washington and W.B. Du Bois about how do we educate the Negro so that the whites in the South don't get upset about the education of Blacks. And so there was this idea that Blacks should only get vocational training, and that all the other, that was Booker T. Washington's point of view, and W.B. Du Bois had this notion that they should be the talented 10% should be allowed to go on and become anything they want to be. But this guy Boucher already has his PhD. So that's another place where physics actually sort of steps in and says, let's see what you guys are, let's see what the truth is. Darwin's big problem, however, was that the Earth had lava. And why is that true? Well, Darwin's theory of evolution, any version of it, will require lots and lots of time in order for evolution to work. But people were seeing when volcanoes erupt, they would see hot magma coming out of the Earth, and they would use Newton's law of cooling to say, well, if the Earth was as old as Darwin needed to be, they were thinking like 1 million years. There's no way that you could still have this hot magma in Earth, because Newton's law of cooling would have cooled it off in about 8,000 years, no matter how you think about it. That was the argument made at between pretty much 1850s to 1900. But science responds again with this same question. And this time it's Madame Curie who comes along and says that the reason the Earth is so hot has nothing to do with Newton's law of cooling. It has to do with alpha and beta decay. And alpha and beta decay is what keeps that radiation, it keeps that radiation heat is what keeps Earth's core so hot. Now, Madame Curie, this pretty much destroys all the scientific opposition to Darwin. And pretty much after Madame Curie's work, most of the scientific community said, okay, Darwin's got a good point. And it actually shattered the conversation about even about the education of Black people. And it may have led to the race riot in 1905 in Atlanta, Georgia, due to this educational question. Those questions I do not know the answer to, but you can imagine that it's right around this time where people are realizing that Darwin has a point. Negroes do have souls, and there's something wrong all along with all this other stuff. And so this starts to culminate into bigger problems around 1900. Now, one interesting thing about Madame Curie, she's probably the first sex-shamed person in the scientific community, and the news was so horrific that she was actually seeing Paul Langevin. And if you read the newspaper, which I think you should go ahead and read it in English anyway, it's like the Paris Times. You'll read that they actually call her a Polish immigrant in order to insult her. Okay, so it was an interesting time how they would racial slurs of any type were considered open game in the newspapers. All right. Around this time, our second African-American physicist with a PhD in physics was in 1918 at the University of Michigan, him and his advisor. They had discovered that this interesting idea that if you look at molecules and vibrational, their rotational modes and degrees of freedom like that, they seem to also have this quote unquote quantum feature. And at this time, that was not believed that quantum mechanics had anything to do with larger molecules. They thought maybe this was some cute property of the electron or maybe just the photon. But the fact that the idea of the universality of quantum mechanics can creep up in something at the scale of a molecule was indeed a brand new discovery. And so this guy Imes actually turns out to have a pretty nice physics career compared to Boucher. Boucher simply could not find a job. He worked in Pennsylvania for a high school for colored students, which is a good school for kids to go to. And I think even my father in St. Louis went to Soldan, and he actually worked for a short period of time at Soldan High School in St. Louis, Missouri. Now, Einstein is well known for his the Einstein-Hilbert action, as well as his Einstein equations. So let me just end with a quick discussion about Einstein. Okay. So Einstein's known for this. However, why is it that physicists don't know about the rest of his career? That's a good question. But I think it's because we're probably too busy trying to figure out what the hell this stuff is. Okay. And this leads to the Bianchi identities, et cetera, and the Einstein conservation laws. And he leads to, and it's interesting that how important Emmy Noether was in just going from just this equation here. And so she was a mathematician. I don't have time to talk about her, but she was another major player in just getting this side of the equation right. And it's believed that Einstein might have had this equation several years before his rival Hilbert, who actually had employed Emmy Noether, could actually catch up with him. So Einstein was big in civil rights in the United States, and you can see this. He develops this theory. Okay, fine, but he's also sensitive to the fact that that he's a Jewish person in the United States, and that there is some issues. But what happened right after World War II? There was the Tuskegee experiment. There was all kinds of soldiers, black soldiers, which are involved. But when they came back home to the United States, it was not very welcoming. And in particular, one black soldier was lynched in full uniform with his wife, and there was a sign that said, "Here hangs your nigger hero," in plain sight. And this upset Einstein so much that he actually wrote a strong letter, open letter, and which I'll show you in a second, which just literally changed the way he thought about American politics. Turns out he and Paul Robeson also supported Henry A. Wallace. Now, Wallace was the vice president of the United States. He was from Iowa. In 1941 to 1945, he was Franklin Roosevelt's vice president. But Wallace had these crazy ideas that somehow desegregation, anti-lynching laws could be put into American politics, and it was just. And he also had made this claim during the 1944 Democratic Convention that women should be paid the same amount that men should be for the same amount of work. This is so radical that Roosevelt said he couldn't keep him as a running partner. So they got rid of him and put in Truman instead. Robeson actually started what is called the Progressive Party later. But here's the letter that Einstein wrote in 1945, challenging Americans to pay more attention to a deeply embedded social sense of racism. And I will let you read it here while I catch my voice. Okay, I think I have my voice back. So Einstein is firmly against this. He really pretty much actually doesn't visit any universities for a long time. And the first university he comes out and visits is Lincoln University, which is a historically black college university. He worked closely with this guy, Paul Robeson, and he was one of the co-founders of the American Crusade Against Lynching. And so Einstein himself had a strong civil rights component, which is almost never mentioned in American discourse about civil rights. W.B. Du Bois was the guy who I just mentioned from the Atlanta argument. He said that he was the one who believed that Black people should be able to study anything they want and not just vocational training. Was actually being arrested when he was 83 years old for being a foreign agent. And it was Einstein who stepped in and actually said, leave the guy alone. However, it didn't take long before Einstein himself became under investigation. And here you see that the J. Edgar Hoover actually plans to indict Albert Einstein for derogatory acts against the United States. And he is under investigation, but Einstein just died, didn't care about it. He just, okay, I'll just go ahead and die. You worry about that yourself. So he never was, he never had to testify because he died. And another interesting thing about Einstein, as well as just to show you how twisted physics really is with the characters, is that it's a Catholic priest who actually comes up with the idea of the Big Bang Theory, Lemaitre. And Einstein didn't particularly like the idea that the universe had dynamics in its own right. However, when Hubble actually made measurements which agreed with Lemaitre, so I'm sort of twisting the history a little bit, but you get what I'm saying. Okay. It turns out that Einstein actually says, okay, well, cool. I mean, I couldn't solve the differential equations, but he could. So Lemaitre solves them. And so you see that he is that Lemaitre actually shows up at the New York Times quite a bit, by the way. If you look at the New York Times, anywhere from 1929 to 1933, and you put Lemaitre in there, he was a very famous priest, simply probably because he's a priest and he worked on these differential equations associated with Einstein's work. So he had to get himself a photo shoot of with Lemaitre in it. So my final statement is that for the students, especially out there, because most of us actually know this, the real world is highly complex. We are people who actually are working. This was my research group, my summer research group a couple of years ago. Well, it was more than a couple of years ago. This is Professor Gates at Brown University. He's there again in Brown University. And if you just say, who wants to do physics? Okay, you can get all kinds of people. You don't really have to do much, but you say, you hang out with me. None of these people were paid, and they worked for 8 solid weeks on publications and ideas and stuff like this, which we played with. So it's actually possible to just to do physics. You just have to want to do it, and you can have fun with your subject. So this is Paulette Willis when she's young, and I'm firing off a ring with magnetic fields here and making her chase it down in front of the audience. So this is an example of having fun with the subject. She liked it so much that she actually got her PhD. And one thing I like to tell the students, okay, is follow Dr. Young. Dr. Young had a hard life, okay, as a zoologist, mainly because she was sort of poorly mentored. But nevertheless, she got her PhD in 1940, the first Black woman to get a PhD in zoology. But I always liked what she said, that it's not failure, but low aim, which is a crime, okay? So later on, you see myself and my colleague, Sarah, actually hooding this Paulette, who gets her mathematics PhD at the University of Iowa. So that's all I have to say. Anybody have any questions or want to play with the idea some more, let me know.
Yeah, thanks for a wonderful talk, Vincent.
Thank you.
Okay, so now the floor is open for questions, if anybody has questions for Vincent. I had some questions. So you mentioned these the first few African Americans getting a PhD, but at what year or who was the first full professor who was from Africa? I mean, who was the first African American full professor in US? Do we know that?
Nope, I don't. At some point, I do not know. Okay, I do not know. But when you count professors, I mean, for example, Imes was a professor, but are you counting HBCUs? Because Black people invented another whole college system in order to go to school, right? Mm-hmm. Called HBCUs. And some people don't want to count that as an American university. But American universities, HBCUs were around since the 1830s. And so it depends on what you want to count. If you want to say Yale University, who was the first Black to get become full professor at City College? I mean, is there an answer which is non-zero?
For City College, I know the answer. I think it is Kenneth Clark.
Okay.
Yeah.
Is he physicist?
No. He became a full professor in, I guess, sociology. He was very influential in writing doing a study, and his opinion was quoted in the Brown versus Board of Education decision by the justices, actually. So he was a very influential figure.
Yeah. So the academies do play a part. I mean, what is it called? Phi Beta Kappa was they actually asked this guy Boucher to become a member. So they were like, "Well, they're really impressed." So he was also one of the few Phi Beta Kappa members at the time as well. I think Dubois was also Phi Beta Kappa, but I don't really pay much attention to it. I like Boucher because I like physics, right? So I paid more attention to physicists and chemists and zoologists and stuff like this. And I mean, Boucher is also very well known as someone. My father was a editor of an African-American newspaper in St. Louis. So we would hear a lot about African-American history, but not very much about anything in the sciences. That was why I was sort of curious with what's going on with the Boucher.
Tony has a question. Tony, go ahead.
I had a question. Professor, you mentioned that early on in your lecture about the speed with which the galaxy, the Milky Way, turns, and how you compared it to the time of the dinosaurs. And I was just wondering, does our galaxy turn faster than others? Or do they all turn around the same speed, or what?
They have different speeds depending on their matter content. I mean, there's a rough approximation, but I should probably ask Aiden, who's an astronomy student. Okay, what do you think, Aiden?
While the universe is relatively homogeneous in terms of composition, it depends on a lot of things. The rotational rate at which a galaxy spins, it can depend on mass, can depend on the sort of model of the galactic potential that you choose. It can depend on a variety of things. In general, we associate a tangential, like a rotational speed of about 220 kilometers per second with the Milky Way.
Thank you.
That's a way better answer than I could have given you. If there's no more questions, let me put in a shameless plug that I will be giving a seminar on Friday at the high energy theory group. Okay, we're talking about my research with string theory and perhaps an origin of dark energy and dark matter. So a mathematical origin, anyway.
Actually, there are a couple of questions. I think Carlos Ordaz.
Yeah, I have a question. So you mentioned in your talk that the world and people in general are very complicated. And very recently, I was very surprised to find out that Heisenberg was a member of the Nazi Party, and that Fermi was a member of, I think he was a member of the Fascist Party in Italy. So in physics, we have statues, so to speak, to people who have made great contributions to the field. And what we usually do is we name the equations after their discoverer, right? So I guess my question goes along the lines of, how do we reconcile these great breakthroughs that these people have made with some very dark and problematic issues of their personal lives?
So as an undergraduate, I would always sort of ease my pain of solving second order partial differential equations from electricity and magnetism by reading history books, and Heisenberg was one of them. So I read Heisenberg's biography where he explains his Nazi, and pretty much you can see yourself getting trapped in that if you read his book carefully. You know, he writes it after the war, so let's just assume that he knew what he was doing with it. But the point is that when he did not expect Hitler to go into power, and he said a lot of Germans didn't. They just thought everyone would see that that's just not going to happen. But he wakes up one morning, and every scientist becomes part of the Nazi Party. And so he was asked to work on the bomb, okay, because he thought, and he claims that in the book, which, you know, which I'll have to take as honest, that he simply said, you can't do it. And he was sort of ignored then by the Nazi Party after that point, okay, and so I think Heisenberg's case, you see people being trapped, and because you can wake up one morning, even here in the United States, you don't know, I'm not particularly sure I would have enjoyed being in every war the United States was ever in. You know, I don't think that you just wake up and you're part of that civilization, which has gone to war, you know, with other countries, because you're a citizen. And I don't know anything about Fermi, okay, but Fermi is also in Italy, and no one expects their town to be, you know, to be overtaken by people, dictators necessarily, you know. So scientists are caught off guard a lot of times because we have our heads down. And in a conversation I just made with my graduate students here, it wasn't until recently that scientists even took politics very seriously. It was only in 2007 or 2008, there's only 4 members of Congress who had science degrees. But now, since 2016 or 17, There's been a wave, and there's about 50 members of Congress who have science degrees. So it's a question of, do scientists really think that our civilization is taking care of us, or are we really just waiting to use the work of science? Okay, so I think they were caught off guard. That's my opinion. Carlos, did
Thank you.
Einstein visit other HBCUs after Lincoln? Yes, he did. Okay, that's in his memoirs, actually. Can I see the slide with Einstein's letter again? Yes, you can. I'm reading the chat stuff on the side. And this is a short version of the letter. There's a longer version of the letter on the Phi Beta Kappa website, which I have on a LinkedIn site somewhere.
Thank you.
Let me push this button. Try it again. Okay, I hope you can see. Well, maybe not. Sorry, that did not go well. There it is.
So Vincent, while people are looking at this letter, may I interject one additional comment about Heisenberg? First, to Carlos as well, who asked the question. There is an interesting book about the history of Heisenberg's involvement in the war, which is by Thomas Powell, an American historian, and it is titled Heisenberg's War. And it also contains at the end the farm hall transcripts, which were released around, I believe, around 1900 or so. Sorry, 2000, 1995 to 2000, around that time. So it's a very interesting reading. And I agree with you that Heisenberg was caught in many ways. And yes, he did have involvement in the German attempt to make the bomb. And he and von Weizsäcker were actually asked to do it by Albert Speer. But he also had other sides to him, namely, he, for example, was vehemently against attempts by certain people to label Einstein's work as Jewish science. He was completely opposed to that. And he is also on record as having tried to help many Jewish students of physics during, in whatever way he could, including the famous Euler of the Euler-Heisenberg-Lagrangian that we know. So that's just a short comment. But this book I mentioned is worth reading.
That kind of complexity that Paramahansa is talking about, you even see it with someone even like Abraham Lincoln. He's twisted with this whole idea of should he emancipate all slaves, or just the slaves from the South? All these questions. Mm-hmm. People are in a situation, and it's really hard for us to. I mean, are we willing to be the pioneer who risk their life and everything for a certain decision? It takes a lot of courage, and I think a guy like Lincoln, who gets a lot of criticism, actually did the right thing. I mean, he took a bullet to the head for saying that blacks should have the right to vote. And now let's take an example of that whole situation with women's rights. Women aren't allowed to vote at the time, only black males. And so it actually caused friction between women voters, people who wanted women to have the right to vote, and black and blacks to have the right to vote. What is it called?
Suffragette movement.
Hello?
Suffragette movement.
Suffragette movement.
Yeah, so people are trying to say people like early women's suffrage movements were racist. because they didn't agree with the amendment, 14th Amendment, okay, things like this. But that's not what's going on. They're not agreeing with because they want to also be part of that amendment. And they're like, don't ask me to be part of an amendment where you leave me out of it. But that doesn't make them racist. It makes them looking at an opportunity to just slip through their hands. And they were right. It took 50 more years. These people are dead by the time women had the right to vote. So it's one of those complexities where you're caught in a system, and black males could vote 50 years before women could. And even now, 100 years after women have a right to vote, we're still seeing the ramifications of that long, hard, drawn-out decision. It's going to take several more generations before it becomes being like left-handed and right-handed, where people just don't care anymore.
So there is a question in the chat.
The recently Chileans, yeah, I mean, anything that any civilization which is using mathematics to develop something. I mean, you don't have to be the first, but you just have to appreciate the fact that people were doing things this way, using calculations, and I think that's the point. It's not when I'm not in a race to be the first anything, you know, because I mean, I have a twin brother and I was born 1 minute before him. So I guess I already won the one race which really matters. But outside of that, I have no. So I think if you find anything which is like this, the calculations of the Chaldeans, okay, then that's good. That shows you how embedded science is in civilizations. But if the only thing we know about a civilization is people say, oh well, they sacrificed virgins, okay. That misses the whole point. That's what I'm trying to say. You know, that's all you can remember about a civilization. Anything else that?
So nuanced thinking is the operative word, it seems.
I'm sorry?
Nuanced thinking about history is an operative word.
What does that mean?
Means it's more complex than just right or wrong.
Yeah, that's right.
Okay, so if there are no further questions, let's thank Vincent once more for a wonderful.
Yeah, just to elaborate on my question a little bit, I wrote that question. It's just that we are actually aware of archaeoastronomy from like the sense of there's the Grodnik circle in Germany, and then like things like the Nabta Playa or Stonehenge. The thing is, when would you like characterize the first step where astronomy was really done in the mathematical sense? So like to really study the motions of the planets, and because from what I'm aware